Your message doesn't look like
I'm going to see.
It makes it difficult to know if I'm with Florida.
So many shows.
Well, I guess I could look up. I know they're. Oh
No.
Thank you guys for coming to find weather pattern range. We have addressed today who's a retiree of the department, and you'll be doing the weather briefing. So take it away.
Always start off with an old age joke, huh? Retiree. So I understand that the Weather Channel had some sort of headline that a mega block. What was it, Ben?
The mega block is hitting millions.
Well, we will talk about a blocky upper air pattern over the contiguous states next few days, but I promise that I won't say it's going to hit us or hit millions. And what was the other? It smashes into the polar vortex or
Polar vortex. Something else is making seasons collide.
Oh jeez. Oh jeez. Oh well. I got up very early this morning. My dog wanted to go out, so that's when I put together the presentation. So I apologize if. I guess it's thinking. Is it slow to load the browser?
It can't be.
Yeah. Wow. See this? I almost decided to make animated GIFs, and I should have. But what you think the Penn State e-wall would be easier?
I think you all is open in Firefox. It might be Internet Explorer.
There we go. Okay. There is actually a high latitude block slowing down or disrupting the flow at higher latitudes, and in time, I'm looping over 2 days. So basically, this is the 12Z run, I think. No, it's the 6Z. That's okay. So 6Z this morning to 6Z Saturday. The upper air pattern doesn't change all that much. And this high latitude block, what characterizes a block is dramatically meridional flow. Typically, there's a split in the flow and enough mass being carried in a sort of a southern branch of the westerlies. That's what you look for in a block, although these days on television, blocks come a lot cheaper than that. At any rate, this block breaks down in time, and another block sets up over the Middle West and the Northeast. That will be music to anybody's ears who's going to the game or doing a lot of cycling this weekend like I am. There is early on, you'll note this sort of closed low sort of trapped in the ridge. It sort of dissipates. But there's another really short storm trough leading to the southeast. Notice that it's an open wave for a while, and then it closes off as it gets into Arizona and the southwest. And of course, anybody who's taken 411 knows that at 500 millibars, you're close to the level of non-divergence, and absolute vorticity is conserved. So that means as you go south, you lose F, planetary vorticity, and you have to gain zeta, relative vorticity, and that's manifested in increased curvature. And so the open wave, as it dives southeast, closes off and intensifies. That low is going to have a big player not only in western weather, but in the Midwestern weather in the short range. just throw you a little bit of water vapor imagery. See how this loads. That's doing pretty well. From the University of Wisconsin, 3.5-hour loop of water vapor. And remember, from water vapor images, you don't assess low-level water vapor. You can get a handle on a wind, upper-level winds, mid-level winds sometimes, and the white things that you see are not is not water vapor. That's high cloudiness. Actually, it's cirrus associated with the jet stream in this case. But that wave that I was talking about that in the short range dives into the southwest, you can see it just entering the Pacific Northwest. It's sort of weakening now, but later this afternoon with cold air aloft, there will be some thunderstorms in the Pacific Northwest, and then another disturbance out ahead of that will increase the chance for severe weather over northern Montana into the northern Rockies. And that's exactly what this is the day one convective outlook from SPC, and you can see there's a marginal, that upper level low is diving southeast, so there will be thunderstorms, particularly in eastern Washington and eastern Oregon, where there'll be some low-level solar heating that means some business and cold aloft, and so there could be some thunderstorms. I should have pointed out disturbance sort of rounding a bit ahead of that diving upper level low, another disturbance moving into the northern Rockies. They're sort of it's still marginal, so it's no big shakes. Oh, I did actually put that. I did actually. Let's get the 12Z this time. And you can see this max sort of pinwheeling around the upper level low. That's the vorticity maximum that helps to increase the threat of severe thunderstorms in Montana and areas around that. But again, no big shake. Southern California, typically when you see a strong short wave diving into the desert southwest, that can only mean wind for Southern California, and I believe the high wind advisory has not already gone up in Southern California. I'd be surprised, and I'm sure it'll be changed to a high wind warning. Let's see if I can get the 12Z, and let's just loop 2 days. And here comes the sort of the signature of that upper level low at 850, and it takes shape. Down over here, you can see the big gradient at 850 millibars as this thing gets established in the southwest, and that's going to produce northerly to northeasterly winds in the mountains of Southern California. Some of them will squeeze through the passes. Even the coast will get quite breezy, and of course, any easterly component, the low levels warm up, so temperatures. Tomorrow especially will be 5, 10, maybe even 15 degrees above average in Southern California. So a pretty good wind event over the next 48 hours in Southern California. Let's see. I guess I could point this out. Why not? I threw it in this morning. I can't even remember what I did. But as that upper level low gets through, and there will be a surface cold front that passes through Arizona, New Mexico, western Texas, with the gradient aloft and a lot of mixing, some real gusty winds. It's going to be warm down in these parts, quite windy. Relative humidity, I wouldn't be surprised if you looked at some observations there tomorrow, you would see relative humidity below 10%. And anytime it's warm, the wind blows like heck, and the relative humidity is less than 10%, you got to worry about wildfires. So this upper level low has some far-reaching effects regionally for the West and the Midwest. I mentioned the surface front. This is valid the 12Z Saturday. And there's the cold front, that upper level low moving through eastern New Mexico and into West Texas. As I mentioned, the upper level low has, I got to get to the forecast. John Neese will kill me if I don't get to it. I'm kidding, John. It's good to see you. The flow at 700 millibars is small. Where's 700? 700, right there, yeah. 12Z, 2-day. Broad southwesterly winds ahead of this diving this morning, ahead of this upper level low. Typically when you see, I'm going to stop it here at the beginning so you can see the southwesterly flow that I'm talking about. Right in there. That's the picture this morning. Typically when you see winds like that, you would expect the development of a lee trough in the lee of the Rockies, as told by Lee Grenci. And if we go to the 12Z surface analysis this morning, you can barely see this trough sort of hanging down over eastern Colorado down into northeastern New Mexico. A lot of that has to do with lee troughing. You'll learn about that. You do lee troughs in 411, don't you, John?
Eventually.
Eventually, okay. Well, ahead of that lee trough, which is actually going to turn into a dry line, actually, if it hasn't already, later today, we got a number of things going on. I'm going to choose 925 millibars as a proxy for the surface. Remember, from Meteo 201, that's about 700, 800, 900, 1,000 meters, typical height for 925 millibars. You'll note, well, let's see. Let's just, previous, next, start. Okay. Watch the increase in the flow at low levels out of the Gulf of Mexico. I see 30 knots at 925 millibars coming in. Again, this is 12Z Saturday. So towards the end of the short range period, a lot of, there'll be essentially a low-level jet stream out of the Gulf of Mexico, which will help to bring in and advect higher dew points northward. You also can see in time the skinny red lines are isotherms at 925 millibars. There's some frontogenesis going on in the central high plains. The lee trough turning into a dry line, and the cyclogenesis cold front taking shape in the central high plains will be two focuses for severe weather over the next 2 days. Now, it's not going to be a big outbreak, but there will be some severe thunderstorms. I would probably think that large hail will be the greatest threat. There could be a few tornadoes and some damaging wind gusts, but this is not a big outbreak, folks. So let's see, 12Z Friday. There's 12Z Friday, 0Z Saturday. You can see there's the lee trough, still a lee trough, and still a lee trough. And by Friday evening, we've got a dry line stretching down across the panhandles of Texas and Oklahoma. And then there's that cold front that I pointed out at 925 millibars with the packing of the isotherms and cyclogenesis. So the dry line looks to be a focus for thunderstorms as well as the cold front. Mid-level winds Typically, meteorologists look at the vertical wind shear between the ground and 6 kilometers, so that roughly 500 millibars to gauge the type of thunderstorms, the mode of thunderstorms. Let's get the 12Z. Let's get the 2-day 500 millibars. This is 500 millibars. The contours and the absolute vorticity at 500 millibars is shaded in yellows and reds. You'll notice at the end of this period, as this trough closes off again and intensifies over the southwest, the winds over the western high plains really increase at 500 millibars. And associated with those strong winds at 500 millibars is strong enough vertical wind shear to support supercells. And let's see, hopefully the SPC, when I looked at it this morning, it had pretty much the same thing. A slight marginal chance of severe thunderstorms over the western high plains, pretty much in the area where the dry line was and where the frontogenesis was with that approaching cold front. The interesting thing, this is the North American model 39-hour forecast from the 6Z model run this morning, valid at 21Z tomorrow afternoon. And you can see, anybody know anything about dry lines? These are dew points, by the way, surface dew points, 2-meter dew points. Pretty good gradient associated with that dry line that I showed on the WPC surface forecast. And of course, there's also a dew point gradient associated with the cold front that's moving in over the central high plains. The reason I wanted to show this was that there's going to be severe weather on the western high plains, particularly the southwestern high plains, tomorrow and probably into Saturday. But tomorrow, I wanted to just point out that some of those supercells that develop will be developing with dew points in the 50s and perhaps even the 40s. So the idea that you need 70 dew points or really high dew points to get severe weather is not necessarily true. I did not look at the precipitable water. I should have, but my guess is that these are going to be high-based, low precipitation kind of supercells, and they could produce some damaging hail. Just for the heck of it, I got the 39-hour North American model sounding in Amarillo, Texas, which is in the panhandle of Texas. This is also valid 21Z tomorrow afternoon. Excuse me, 12Z tomorrow morning, sorry. And you can see that there's a pretty good inversion, 850 on up. A lot of convective inhibition that has to be eroded before these supercells develop. And of course, the solar heating and the approach of the cold front and the dry line will help to erode that convective inhibition and get rid of that capping inversion and set the stage for some severe thunderstorms. Back over the northeast, getting there. Just to refresh your memory of the omega block that sets up over the upper Midwest and the east. Meridional flow. There's some flow along the edge of the southern branch of the westerlies, but pretty much this block sets up over our region. It doesn't move. So the idea that we're in a kind of modified persistence forecast makes sense. Just look at the 850 millibar winds. Not only are we going to have sort of wall-to-wall sunshine, but for the cyclists in the group, the winds will behave themselves, so we can. I got the wrong thing. I meant 850. I was going to show you the 850 millibar. It showed light winds at 850 millibars. In fact, there's the 21Z. That's tomorrow, April 15th. That's the 21Z forecast sounding from the NAM at University Park, I believe. Yes. And you can see essentially a well-mixed boundary layer up to 850 millibars. Very light winds in the boundary layer from the southeast, 5-10 knots. So any type of mixing, the winds are going to behave themselves. In a modified persistent forecast, I mean, a lot of people will just look at the high one day, add a few degrees for the next day, and call it a day. So when I used to teach forecasting, I would talk a little bit about the delta method. In a nutshell, the dynamic models don't predict surface temperature, surface dew points, surface winds very well. A lot of parameterizations that go on near the surface, these sort of mathematical models that are imprecise. But what dynamical models do is they can predict the change in those variables pretty well. And so the delta method takes advantage of the ability of the dynamical models to predict changes in surface temperature, surface dew points, surface winds, ... over time. Just give you a quick example, not to run over, just look at the high yesterday in Altoona, 12.8, 55 degrees, nice day. So we don't have the high today yet, so I'm pretending like I'm forecasting yesterday for today's high, okay? And if I look at the 2-meter temperature, and I'm going to look at the 18C temperature at Altoona at 2 meters, 49, and then the change to 18Z today is 5 degrees, 49 to 54. Now this is the NAM. I'd have to do it for the GFS and do some sort of blend. But if you just take that change, a good forecast might be 60 degrees for Altoona today as a high temperature. You can use the 850 as well. At 18Z, yesterday went from -3 today to 0, which is an increase of 3 degrees Celsius. 3 times 1.8 is 5.4. That's another 5 degrees. So assuming that the boundary layer is well mixed, what happens at 850 millibar gets 850 millibar gets translated down to the surface. There's another 60 degrees. And there, I just showed you the forecast sounding for this afternoon at Altoona, and it is well mixed. So using the 850 millibar data is okay. NAM Moss at Altoona, high temperature 59. So the delta method works. GFS Moss predicting a 58 for Altoona today. So in the ballpark. And I would probably, just splitting hairs, probably go 59 because of those easterlies and southeasterlies. A little bit of upslope might keep us in the upper 50s, but who's counting? Did I finish on time? Wow. I'm tired. Are there any questions? So the Omega block will hit millions.
That's why you're tired. Yeah.
That's right. I'm fighting it off. The bottom line is get out and enjoy the weather in the next couple of days. We deserve it. So I think we'll be in a few degrees every day, 60s, toward mid-60s tomorrow and Saturday, maybe into the 70s on Sunday. Good day for the blue-white game. Thank you, everybody.
Wait. Next week, we get ready.
Thanks for coming, Dave.
Thanks
Well,
for
I'm
having me.